Okay, so we'll do this. We'll split this into two parts again. But the first part, so that we can actually really concentrate. I think the first thing here is that you really want to make sure you have done some mock papers um, with these, because these are standard marks. You can almost call ideal standards. Um, oh, right, right. Sorry, forgive me. It's just coming on and giving me the option to write. This is not. I actually thought all right, so I think it saved it as a, right. So these are perfect standards. You can almost call these machine standards. Now remember, you have 2 marks. So what you want to show the examiner, because you want to pick up all marks here. These are perfect, and they do not take any they do not take any idle time into account. And when I say idle time, expected idle time or expected losses, right? I think is the point. Um, and you will expand on this later on, but you could argue as being the sort of the perfect benchmark to inspire. Well, a perfect benchmark. It's more an awareness. The important thing is having an awareness of what perfection is, if you think about it that way. Um, or a perfect no wastage scenario. That's the key point here. And you could almost go, what we're really arguing is we can go right all the way to the extreme. And so you can argue that these are probably the initial standards set many years ago. And the ultimate point about them is to use them as a reference point. A reference point. There is nothing, they're not current. There's nothing current about them. So the argument is, I suppose the argument is old, but I don't know if old is a technical term. I think initially sets standards um, in the system, but are good as a reference point for trend analysis, really. So suitable for trend analysis. So set many years ago, not current, and if you like, not really relevant, not relevant, right? Yeah, I think those are the 2 points. But the key point about characteristics of each of them, they are initial standards. They're set many years ago. I mean, I think please look at the mark scheme, of course, but I don't think the answers will be too far away from what I'm doing. Okay, great. So yeah, so we now have this question. Now, and it's really about the structure here. So this question says here that they produce handmade boxes, existing standards. These are the existing current standards. So you're kind of what we would call our sort of attainable operational standards. And what I want to do is, it's not really, there is no question to per se answer in terms of numerics, but I think it's important. So packaging, ingredients, labor, and that's your prime cost. So they use ideal standards for ingredients. So they use ideal here, and we do have a question, I think, well, definitely, and ideal, and here we have basic. So I think what you want to do very carefully, you can see it says 9 marks. So what you really want to do is that you want to almost have a scenario where you're clearly talking about ideal for ingredients, ideal for packaging. Fair enough, you could talk about the two together, and basic for labor, and have some kind of, if you like, sort of, I would argue, some kind of relationship heading in how they affect each other. And then, of course, in there, you're talking about how they affect employee behavior, but very clear. You're clearly answering the question. You see, I think that's the problem. You're not just waffling everything all together. No, you will not you need to be very clear. So let's start. So the key point here is that if you have ideal standards for ingredients, in terms of, remember that ideal standards are to do with, and I think that's what you want to do. You want to talk about what these variances are. You want to sort of um, this question of pricing and usage. So you're using, if you like, perfect standards for pricing and usage. And So the argument here is that you're expecting them, if you like. So first of all, you're highlighting that you know that variances, this whatever total variance you're going to have, will be broken up into price and usage. So you're expecting them to buy the ingredients, the raw materials for the ingredients, at the perfect price, and to also use the ingredients, the actual ingredients, if you like, at the. So this £2, for example, could be made up of £1 times 2 kg. So what you're really saying is, I'm expecting you to use exactly 2 kilograms, 2 kilograms, and to spend exactly £1 on each kilogram. So you're really highlighting that, listen, it is possible that they will not be using 2 kilograms because we do see wastage. It's possible. And it's possible that you may not, there might be external factors, of course, with outside their control that they don't know. Or there is a shortage in supply shortage, and they're not going to get this £1. So the question is, the ideal standard does not take into account any of these factors, right? So those are the two issues. So now the question about where in a way, I think you should answer this like this, and then write employee behavior under each of them. There's no problem with doing that because it means you're clearly answering the question, and how this affects employees. Because the argument is that employees might be likely to be demotivated, demotivated if they feel they're going to be judged on that variance because you're asking them to use 2 kilograms to make something, but really there's wastage of maybe, I don't know, 0.2 kilograms, and they're actually using 2.2 kilograms, and you haven't taken the fact that this thing is there will always be wastage with anything you do. So the best thing you really want to do is to set the standard to take into account. So that's what you're really saying. You want to set the standard to take into account that wastage. Um, the other issue here about relationship here is that um, you might just not have very efficient people working for you. And so, because you don't have very efficient people working for you, yes, you want to use 2 kilograms to make each item, but inefficient labor. And when I say inefficient labor, laborers who just does not as good, number one, laborers who are just learning, who are just training, will probably use more kilograms than they should. So you can see there's a building relationship between ingredients and packaging and labor. Right. So the fact here is that if your labor force is not as qualified, now what is the issue there? The issue here, in exactly the same way, is that with labor, we notice that you have price and efficiency. Generally, if you're getting cheaper labor, they are likely to be not as experienced, and so will need more time to understand how they work on the product, and will also end up being inefficient. So that's that. And I think what you should also mention is this idea of machines, the extent to which machines play a role in your business. So the key point here is, if you have machine breakdowns, or if you have stockouts, you will also have labor inefficiency. It'll look as though the laborers are taking more time to produce something than they really are. So I think those are some of the points there that you can address. I think what I should do is really go to the answers and see some of the things they're looking at. But I think the answers are not as I think the answers are quite bland. I think what you really want to do is to break up each issue into its component variances, so price and materials, or price and usage, and discuss each separately. So you see, for 9 marks, you're talking about these three things, and also talking about the relationships. You're definitely in the 6 to 9 mark ballpark, which is where you get the perfect marks. But just writing everything as a whole is not a good idea. So separate each one into their different variances, and then talk about the relationships, the very clear relationships between material and labor. Now, the other thing, the other flick side to this, of course, yes, let me just clean this out just to sort of highlight this thing about relationship, yes, which is important. So the two relationships, here are the relationships, here are the relationships. The relationships are here, and I think it's important to highlight all of them for all the marks. Now, the first relationship is internal. Say, for example, we're talking about material. It doesn't really matter. We're talking about material or labor. The argument here is this: if you get cheap material, as in, and you get cheap labor, you are likely to have wastage because the material is cheaper. And if you get cheap labor, you're also having likely to have greater labor inefficiencies. That's the point here. Now, the secondary point here is that if you have cheap material, that could also lead to labor inefficiencies because you have material wastage, but you also have labor that is not able to work well with it. You know, the material is not very good, so they might just lose motivation and whatever, and not be very good. The other point, of course, here is that even if you have good material and you have inefficient labor, so good material, just think about it, and you have inefficient labor, you are likely to have material wastage as well. So you have good material, but you have inefficient labor, you are likely to also have wastage as well of that material, which might be due to cheap labor. So I think it's just about laying it out in headings and then and working in that way. And of course, as usual, just send me your answers as we've discussed, and we'll talk about them. Okay, great stuff. I think that's why I wanted to break this into two parts, and so we'll go into the next bit now.